demystification of the OSI model. Should I remind you to subscribe now or later? Maybe later. So we've reached the transport layer, right? And we've mentioned that either TCP or UDP are used. Since routing and switching are the core of this series, that makes the network and data link layers the most important one for us. By the end of this video, you'll know why. As we move forward, we'll eventually start using some networking vocabulary. Some of that vocabulary is segments, diagram, packets, and frames. Let's clarify what's what so that we know what we're talking about. If you remember when we talked about encapsulation, when data get past the top 3 layers, it gets slightly bigger because of the headers, but it's still called data. Depending on the application, either TCP or UDP headers will be added to it, right? If it's a TCP header, it will become a segment, and if it's a UDP header, it's a diagram.
Oh, segments are larger because of the added reliability by TCP.
So segments and diagrams are a transport layer thing. Then it will get passed to the network layer, and a header will be added to either a segment or a diagram. It's likely an IP header, and that's what's called a packet. So packets are a network layer thing. Then when a packet reaches the data link, a header is added to it, and that will become a frame, then turned into bits, zeros and ones in the physical layer. Adding those to our vocabulary is a must. The header that we added in the network layer contains 2 important information: IP source, where the packet is originated from, and IP destination, where it is going.
It's like when you're sending a letter.
One side has the address of the destination, for instance 44 Lemon Street, New Zealand,
and the stamp right here,
and the other side has your address, or return to sender address, your place. This is the equivalent of the IP destination and IP source. If we ping a website from the command prompt, for example www.bbc.co.uk, DNS will tell me that this is the IP address of that website. So that is the destination in the IP header, and the source is the IP address of my computer. There's that NAT that might change the source as it goes to the internet. We'll look at that when we get to subnetting. For now, just think of it as the IP address of the source machine. So that is what's in the IP header within the packet. Then it moves to data link layer. The header that's added in the data link layer contains 2 important information: source address, where the frame is originated from, and destination address, where it's going. Sounds like a deja vu, doesn't it? Well, not to worry, I'll explain. These are not IP addresses. If I type in ipconfig/o on my wireless adapter, I'd see that I got an IP address right here and a physical address as well. That's called a MAC address, which is unique to every network adapter in the world, and that is what's in the header that's added in the data link layer. The question here is, what is the difference between the two? If you remember in the first video of this series, I've mentioned that requests going to the internet should be sent to the router in our LAN, and that's what this MAC address is for, to find its way to the router or the next hub, not to the final destination. Let's use the letter analogy. I said that this address is the equivalent of the IP address, right? But when the postman or postwoman, to be politically correct, the post person, don't know why it's not applied on the boogeyman. Probably because if you tell your kids, if you don't go sleep, the boogie person will come and eat you, they'll be like, what? The boogie who? Get out of here, would you? Anyway,
the postman will collect it from the post box near your house and take it to the post office, distribution center, what you might call it, not to New Zealand. In that instance, the source was the post box and the destination was the post office building. Then from the post office building will end up in a van to the airport. The source is the office building and the destination is the airport. The pilot is not gonna land at 44 Lemon Street, right? He will land at an airport in New Zealand. So when his sat nav or whatever they're using up there will have source is London Airport, where I am, and destination New Zealand Airport, and so on. You see what's going on here? Every time there is a new source and a new destination, but the addresses on the envelope did not change. The equivalent of these source and destinations that changes are physical MAC addresses in the network networking world.
You see in our diagram a web server here? These two are not directly connected with a cable. They are miles apart. Typically this PC is connected to a switch, and this switch to a router, then to the internet, where there are a lot of routers, and something similar on the other side. Probably a firewall and a load balancer somewhere here, but let's keep it simple. We've seen that the frame will have IP source of this machine, and IP destination of the server, right? And source MAC address of the machine and the destination MAC address of this router. Switches can read what's on the MAC header. It doesn't look beyond that, which makes it a layer 2 device. See, it's like if there are two layers here, where the frame goes up to and the header gets processed. Switches got a sort of database that maps ports with MAC addresses called CAM table. So it doesn't change anything, it just hands it to where it wants to go according to the MAC destination. And that's what switching is. Now it reaches the router that can read both MAC header and the IP header. It's like if there is 3 layers here, which makes it a layer 3 device. So it looks at the MAC destination and think, this is for me because it matches my MAC address. Then decapsulation happens and looks at the IP destination and think, oh, this is not for me. What am I going to do with it? See, routers have what's called routing table, where they keep information about where networks live. So it will look at it and decide that the way to reach the server is through this guy. And that is what routing is. It doesn't change the IP destination, but when it goes down to carry on its journey, the MAC source will become his MAC address and MAC destination of the router in the next hop, which is this one. Same thing will happen here. 3 layers, looks at the MAC, think, oh, it's for me, looks at the IP address, oh, it's not for me, looks at his routing table, he should go this way, put his own MAC as a source and the MAC of the next router as destination, but IP stays the same. That's going to happen again and again until it reaches the last router. The last router will be like, I know where this IP is, it's directly connected to me, and put his MAC as source and the MAC of the server as destination. It will reach the switch and uses the same process as the other switch and send it not this way, but this way, and finally, like Alexa would say, you have reached your destination, and decapsulation will take place all the way to the top this time. To see how many times this happens, when you visit a website, you can use the traceroute command. It's trace RT on Windows and type in the website. I'll leave it cook for a minute and get back to it. So you can see that we just started tapping into routing and switching and how it is related to the second and the third layer and how the concept of the OSI model correlates with what actually happens. That's why I said in the beginning, these 2 layers are the most important one for us. Let's get back to the command prompt. You see, there are 14 hops to reach the BBC website. The word hop is actually among the networking vocabulary and not from the nursery rhyme, hop little bunny, hop hop hop, hop little bunny, hop hop hop. Woof. That was a marathon. I believe we're due for a summary. Okay, we've shed some light on these networking terms right here and dissected network communication between 2 entities. We've seen how routers are layer 3 devices and switches are layer 2 devices. I hope that you've enjoyed this video. If you're not subscribed yet, please do. If you know somebody who would benefit from this, share it with them. And thank you for viewing.